Good day everyone, I am Sir Jerickson Chua and welcome to Animation 1. So before we start our session for today, may I request all of you to please bow your head as we feel the presence of our Lord through this prayer. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Mensuration is all about the process of measurement. It is based on the use of algebraic equations and geometric calculations to provide measurement data regarding the width, depth, and volume of a given object or group of objects. Measurements are obtained by estimating, while calculations are obtained by computing to arrive at a definite answer. Mensuration is often based on making use of a model or a base object that serves as a standard for making the calculations. Calculation is an assessment of the risks, possibilities, or effects of a situation or course of action. In the film animation technology, it has come a long way since the early days of hand-drawn cartoons. Over the years, the techniques used the animation to bring characters to life to have improved dramatically. Traditional animation created the illusion of movement through frame-by-frame manipulation, and three-dimensional images are widely used today by most animations. With the help of technology and animation software, the creation of moving pictures or images are made possible in today's animation. The animation industry is already very dependent on computers to achieve photorealistic textures, colors, expressions, and movement of characters and backgrounds. The advent of computers has helped animation studios to create computer-generated images and handle large amounts of data to be carried out on powerful desktop computers. Our lesson for today is about performing mensuration and calculation. So these are performed by animators to identify what type of computers to use and determine whether the components are appropriate to do the task in the production process. So before we continue with our discussion, let's just have this activity called crossword puzzle. So our aim is to find hardware components of computers in the crossword. Okay, so I'll give you 2 minutes to see and find the different hardware components in this particular crossword puzzle. Okay, there are around 5 hardware components in this crossword puzzle. And I know that you are very familiar with this because you are done with our CSS1. Okay, so I hope you found several items. So we have here the following hardware components. So we have the memory, we have SATA, we have your drive, we have your RAM, and we also have your ROM. Okay, so here are some of the hardware components that are needed to be measured in our subject. Okay, so our learning objectives are as follows. By the end of the lesson, you should be able to first identify the objects to be measured for the job requirement, perform the needed calculations using fundamental mathematical operations, and employ different techniques in checking accuracy of computation. Our key terms are as follows. We're going to identify the different components to be measured. The processor, the memory, your hard drive, your graphics card, your computer storage, and we're going to measure some digital information. So a computer is a powerful tool because it stores huge amount of data and information. Computers come in different styles, sizes, and types. In creating an animation film, it requires a large computer memory to cope with these images during the line testing, digital coloring, and shooting the final film. Characters and backgrounds are already painted by computers. It is essential to know the different types of computer components and objects because each part plays an important role whenever an animation uses the computer. So here are different types of components to be measured. The first one is your memory. So we have your ROM. So ROM stands for read-only memory. So this is a type of data storage where data is permanently stored on computers and other electronic devices. It performs major input or output tasks and holds programs or software instructions that are essential for boot up and are needed to start a computer. So this is very useful for our software components. So the next type of memory that we have is what we call our RAM or random access memory. So this is the most common type of memory where data, programs, and operating system are stored so that they can be accessed quickly in any random order. So the bigger file storage you have in terms of RAM, the better the processes in your computer. So we have here different types of your RAM. We have the RIM and the SIM. When we say RIM, this is Rambus Inline Memory Module, and SIM is Single Inline Memory Module. So DDR means double data rate. So we have here the different types of DDR. We have the DDR module, we have the DDR2 and the DDR3. So they differ in terms of the notches, as you can see here, the placement different from one another, and the pins, they have different pins. So for the DDR, it has about 184 pins, while DDR2 and DDR3 is 240 pins. Okay, and we also have here SDRAM, which has two notches compared to DDR2 and DDR3. Okay, so it has about 168 pins. So each of the computer that we have and laptop has its type of DDR. So you just need to check on what type of DDR your memory have. Okay, so we have here the RIM or Rambus Inline Memory Module. So this memory is expensive and slower than DIMMs. RIM has about 16-bit data bus and has two notches and about 184 pins. Okay, so that's Rambus Inline Memory Module. We also have your SIM, which is a single inline memory module, and it has two types of modules. We have the SIM30 and SIM72. So SIM is measured in nanosecond, which is the measure of access time it takes for the processor to access the data stored on your SIM. So let's continue. So in terms of our hardware components, let's try to differentiate between a cache and a register. So a special very high-speed memory is called a cache. This is used to increase the speed of processing by making current programs and data available to computer at a rapid rate. This allows us to reduce memory access time, thus program execution time is lessened. So cache can be seen on your web browsers. When you type something, it provides you several websites that starts with that particular letter. So that's an example of caching. Okay, next is register. So registers are high-speed storage locations inside the microprocessor. These are designed to access as much as higher speed than conventional memory. These registers are classified into three. So we have data registers. This allows us to hold data for an operation. Address registers allows us to get the address of an instruction or data, and we have the status or flag register that keeps the current status of the processor or result to arithmetic operations. So these are the general types of registers that we can see on our computers. Okay, so the next type of components to be measured is your data storage. So we have your hard drive. So this is a storage device used for storing and retrieving digital information from non-volatile memory in a random access manner. So when we say non-volatile, so this is a type of memory that returns stored data after the power is turned off. So meaning we don't need power to store that particular data. So it's automatically stored on that particular hard drive. Okay, so here are some examples of non-volatile memory. So we have the floppy disk, compact disk, your CDs, we have the internal hard drive, your external hard drive, your flash drive, and your SD card. So compared to our RAM, okay, to our hard drive, so RAM is volatile. It means when you turned off your computers, some of the um, memory that's stored on that particular object is erased. While on this particular type of data storage, okay, your data will not be erased. So through innovation, the hard drive are now changed to what we call SSD. So SSD is a solid state drive or solid state disk. Although it doesn't use a disk mechanism, this is a storage medium that uses non-volatile memory as a means of holding and accessing data. So new versions of laptop nowadays now use SSD, which has about 250 gigabytes of data, and some has about 500 gigs of data. And the bigger size the SSD is, the pricey the laptop is. Okay. Next type of data storage is what we call our optical drive. So this is a storage device that uses light to read and write information such as your CD, your DVD, and your Blu-ray drivers. Okay. So this can be seen on laptops and your personal computers. So we have here some comparison of CD, DVD, and we have Blu-ray discs. So for CD, which we have about 680 megabytes of data. For DVD, we have 4.7 gigabytes of data until 17 gigabyte, and Blu-ray disc has about 27 gigabytes of data. And when we buy our CDs or DVDs or Blu-ray disc, we have to make sure that we buy RW, meaning read write, because when you will be saving some data on that particular disk, you can retrieve those data and then you can replace some data on that particular disk. But if you just bought a read type of disk, okay, so it just allows you to save that particular data on that disks. Okay, so let's continue. Next is your external hard drive. So this is an external removable drive that is typically connected via our USB. So our external drive can have about 1 terabyte of data. Okay. Next is our processor. So a processor, or what we call our central processing unit, is a hard drive device in a computer system that processes the instruction of computer programs. So there are a lot of misconception when we say CPU. So when you see the black box in your computer, that's what we call our system unit, not CPU. So this is our CPU. We have two types of CPU. We have the pinned and the pinless CPU. And it's better to use the pinless because it's easier to remove from your motherboard compared to the pinned one. Okay. Next, we also have your video card. So this is also known as graphics card. So this is a device in a computer that outputs visual information on the monitor. So the bigger size of your video card is, okay, so in terms of storage, the higher definition of our outputted animation videos can be created. Now let's proceed to correct specification of relevant sources. It is vital to know the key components that make up the computer so that one can decide what they want the computer to do and what they actually need. The most important components to consider in reviewing the specifications are the processor, the amount of data storage, and the size of the hard drive. So, specification or specs is a list of key components that make up the computer. Specifications of computer are usually provided by the retailers to help customers decide which combination of features you need for animation. It is important to start by deciding what it is you want your computer to do. This then determines what specification you can actually need when buying a computer. Knowing the specs will enable the animators to come up with wise decisions. So the first information that we need to understand is the processor. So the processors are defined by their speed either in megahertz or gigahertz. It means the number of operations they can perform per second. The higher the value, the faster the PC can perform. Nowadays, processors are designed by two companies. We have Intel and Advanced Micro Devices, which is the AMD. The table on the next slide shows the different levels of processor ideal for a specific activity. So if you want to do entry-level processors, you can just use it for office application, Intel browsing, internet browsing, basic graphics program, home computing, and layout creation. And this is usually done by some offices. For mid-range processors, this can be used by teachers and the like. We have educational softwares, office applications, general multimedia applications, internet browsing, photo editing, vector work, layout creation, and 2D digital painting. And for high-end processors, we can use it for the following: 3D graphics and video editing for office applications, internet browsing, digital coloring, final film shooting, line testing, data processing, and 3D modeling. And for us animators, the standard should be about mid-range, and if you want to create better animation is you can use the high-end processors. One of the main advantages of having a multi-core processor is its smoothness when doing multiple tasks on computer. However, it does not mean that more cores makes the performance of the computer better. Ideally, having a dual-core processor with at least 2 GHz will make user comfortable with the performance of their computer. Nowadays, more computers come with quad-core. Not many applications utilize quad-cores, but they are good to get if the price difference between the dual-core is not excessive. This is because the OS can assign the processor to OS functions and add some processors to the software. When there is a sharing of processor, you can get better response. So as you can see, we have here the difference between the Intel core and we have the AMD. So the latest i-series is about i9 9900K, and they use octa-core and 16 cores. It has about 3.6 gigahertz, and its turbo has about 5.0 gigahertz. Okay, and this will cost you about $488 to have this particular CPU. Next, we have here the latest for AMD. We have Ryzen Threadripper 1950X. This is about 16 cores to 32 cores. Okay, it has the price of $999. And the competitor for the Intel is we have Core i9 7960X. Okay, so comparing between the two, AMD has faster processing power because of its specification, and it's much costly compared to the Intel one. But if you want to have faster processing of the games, for example, okay, you may opt to use AMD compared to Intel series. Okay, so new technologies for animation film has been developed to simplify the production of realistic looking environments. Actor movements are captured with few cameras in a real scene and transferred to a virtual character using high-end computers. The spread of new animation techniques like motion capture, which involves tracking the movement of objects and people, allows us to create more lifelike characters, which depends on heavily on the faster processor. It is important to know that the type of processor will do specific tasks. So here are the different types of processors for entry, mid-range, and high-end. For entry, we can use Intel Celeron and AMD Sempron. For mid-range, we can use Intel Pentium 4, AMD Athlon 32-bit, and AMD Opteron. For high-end, we can use Xeon, AMD Athlon 64X2. Okay? Now let's proceed to memory information. So, RAM is the main memory in a computer that stores and retrieves information. The processor uses this memory to run programs. RAM is measured in megabytes. Most modern computers use DDR2 RAM. Knowing the specs when buying computers or laptops will save users money and satisfy them with the performance they require. If you are a type of user who only use desktop, computer, or laptop for general purpose, the recommended RAM is 1024 MB or 1 GB. If you are a type of user who uses desktop computers or laptops for multimedia applications or high-end graphics, the recommended RAM is about 2048 or 2 gigabytes of RAM. So when animators are doing 3D animation, for example, the RAM temporarily stores those unsaved files before the animation saves them. If the size of RAM is full, the computer will slow down, causing those temporary files to be saved on a different, slower hard drive. Animators need bigger RAM size since they are using graphics applications. An 8 gigabyte RAM is recommended for general graphics work. Next is our hard drive. So, the hard drive is the computer's primary storage area that stores the applications and programs that run on the personal computer. Hard drive is measured in gigabytes, and the minimum recommended hard drive capacity for a typical user who do minimal work on their personal computer is at least 80 gigabytes. For animators who use large graphics and other digital software, the recommended hard drive capacity should be at least 200 gigabyte and above. Save files stored in this hard drive can be gone when hard drives breaks down. It is a must for many users, especially animators, to have a backup file storage. That's why external hard drive is commonly used by many users to back up and secure their files. So here is other data storage that we can use that is not non-volatile. So we have the floppy disk is 1.44 gigabyte of storage. Zip disk is about 750 megabytes of storage. Your CD-ROM, okay, 800 megabytes. Jazz drive has 2 gigabytes. DVD is 4.7 gigabyte. Your flash drive can be 16 gigabyte. And nowadays, we can also have 32, 64, 128 gigabyte, and 1 terabyte type of USB or flash drive. And we also have backup type, 800 gigabyte. And your hard drive can be now at least 2 or 1 terabyte. Now let's proceed to your graphics card. So these are other information that we need to check when buying or identifying computer that we need for our animation process. So the graphics cards are cards that are installed inside your personal computer. So this allows us to produce graphics and images more quickly. Users who do not use their computers frequently do not need faster graphics card. The built-in graphics card should suffice. For gamers, they need to review the specs of the laptop before buying because graphics card on laptops cannot be upgraded. For animators, computers need to have separate PCI, at least 128 MB, and graphics card with faster processor and memory will display images quickly. So we have here the different types of graphics cards. So the first one is integrated graphics. So this is an onboard graphics card that come with standard motherboard. And as you can see, this integrated graphics card, it has its own CPU. Okay. Next, we also have here a peripheral component graphics card or PCI graphics card. These are those that use the PCI slot on the motherboard that is connected on your computer. Next is we have your accelerated graphics port or AGP graphics card, which is similar to PCI cards but have 4 speeds, and the fastest is 8 times. Okay, and the last one is we have your PCI Express, which is the most advanced connection to the motherboard in the PCIe slots, and these can be accelerated to 16 times. Okay, so those are the different types of graphics card that we can integrate on your personal computers. Now let's proceed to computer storage. It is mentioned how most people in animation industry today have gone digital on media and rely on computer storage to store volume of data and for tasks that needs more speed and storage. Many computer programs and applications such as coloring, video editing, and filmmaking requires more disk space and faster computers. The capacity and speed of which your computer runs programs on or completes tasks is determined by great measure by processor speed and data storage. So, in calculating data storage, a byte is a one character of information and it is equal to 8 bits of or 8 digital ones or zeros. And it is the smallest units of measurement used for representing storage capacity. And data storage capacity is measured in terms of bytes, kilobytes, megabytes, gigabytes, and terabytes. So this is the counting of bytes that we can use for data storage capacity. So we have 1,000 bytes for 1 kilobyte, 1 million bytes for 1 megabyte, 1 billion byte for 1 gigabyte, and 1 trillion bytes to 1 is equal to 1 terabyte. Okay, so that is our data storage capacity. On the other components and devices that use byte storage on the RAM, hard disk, space, CDs, and DVDs, and MP3 players, this table is the standard unit of measurement used for data storage. So we use the bit, it can be a 0 or 1 value, and 8 bits is equal to about 1 byte. Okay, and then we proceed to the different units such as kilobyte, megabyte, gigabyte, and terabyte. So this is the size in terms of bytes. So 1 KB is equal to 1,000 bytes, 1 MB is equal to 1 million bytes, 1 GB is equal to 1 billion bytes, and 1 TB is equal to 1 trillion bytes. Okay, let's try to look at this example for calculating data storage capacity. So we're going to convert 100 kilobytes to bytes. Since there are about 1,000 bytes in 1 KB, we just simply multiply the given quantity to 100 KB by 1,000 bytes. So our solution is we're going to multiply 100 to 1,000 bytes. That will be equal to 100,000 bytes. Therefore, there are about 100,000 bytes for every 100 kilobytes. So we're just going to multiply those values. So this is from bigger value to smaller value. Okay, so let's try to convert 5 megabytes to gigabytes. So we'll start from smaller value to bigger value. So our reference table, there are about 1 million bytes for every megabytes. So we're going to convert MB into bytes. Okay, so that MB and GB has similar data storage capacity. So 5 MB is equal to 5 multiplied to 1 million bytes. So that will be 5 million bytes. And then for every gigabyte, there are about 1 billion bytes. So what we're going to do now is we're going to divide 5 million bytes, which is this one, divided by the gigabyte value, which is 1 billion bytes. And the answer will be 0.005 gigabyte. Therefore, for every 5 megabytes, there is 0.005 gigabytes. So that's how you compute that. But I will give you a simple scenario on how to compute it much faster. This is through the use of cross multiplication in mathematics. Okay, so we're going to convert 0.5 gigabyte to kilobyte. So this is from bigger value to smaller value. So what we're going to do now is we're going to get 0.05 gigabyte multiplied by 1000 megabyte, which is equal to 1 gigabyte. Okay, so 1000 over 1 GB, because when we cross multiply, this value should be equal to this value. Okay, so 1 gigabyte is equal to 1000 megabyte. Okay, times we have megabyte here, so MB should be here. So we have 1 MB. What is the value of 1 MB into KB? We have 1000 KB. Okay, so when we do this, we're going to remove, cross, and then we're going to multiply all the values to get 5000 kilobytes. So that is how you compute using the cross multiplication application. And it's much easier using this computation compared to the first two examples. Next, we're going to employ different techniques in checking the accuracy of computation. So, computer systems use many different units of measurement, and the units of data measurement were introduced to manage and operate digital information. Computer storage information in the form of ones and zeros is different types of storage, such as we have memory, hard disk, and USB drives. As discussed in our previous topics, okay, most animation studios relies on workstations with vast amounts of processing power to render large digital information during the production process. For example, if a 4-minute animation film has about 7,500 frames, then each frame has approximately 150 to 200 megabytes. To sum it up, it equates to about 1.5 terabytes of data. It is essential for animators to know the different techniques in measuring digital information for us to better understand how much storage capacity is needed to render our animation films. So a while ago, I have presented to you the different types of data measurement for data storage, but on the digital information, it's quite different because we follow the real data in terms of bits value. Okay, so a bit is composed of binary digits such as ones and zeros, and 1 byte is equal to 8 bits. 1 kilobyte is about 1024 bytes. 1 megabyte is about 1024 kilobytes. 1 GB is equal to 1024 megabytes. 1 TB is equal to 1024 gigabytes. 1 petabyte is equal to 1024 terabytes. And 1 exabyte is equal to 1024 petabytes. Okay? So in the digital information, MB and GB are often used to measure computer storage and memory. For example, 1 unit of this book is about 1 MB in size. The equivalent of 1 MB is 1024 kilobytes or 1048 or 1,048,576 bits. If all books in large library contain 1 TB of information, then its equivalent is 1024 gigabyte and is roughly about 1,610 CDs worth of data. So let's try to look at this example. So we have here a portable document format file size of an animation curriculum guide, which is about 476 kilobytes. How many 476 KB can be stored in a zip disk? So our zip disk is about 750 MB. So what we're going to do now is we're going to convert first 750 MB to kilobytes. Okay? So what we're going to do, we're going to cross multiply. So 750 MB times, we have the 1 MB value here, so that this should have the similar digital measurement. And then 1 MB is equal to 1024 kilobytes. So We're going to multiply this to get KB, so 768,000 KB. Then, what we're going to do now, once we got our KB, because the value that we're going to get is on KB size. So we have 768,000 KB K divided by 476 KB. So 768,000, that is your zip disk. Okay, this is your zip disk. We convert it to the value of KB so that we can divide it to this file. Okay, so we will get 1,613.45 kilobytes, and there are about 1,613.45 files that can be stored in a zip disk. So that's how we compute the units of measure in digital information. Another example, let's try to convert this. How many 20 KB files can be stored in 1 MB file? So we're going to convert MB first to KB so that we can divide it. Okay, so 1 MB is equal to 1024 KB. Then 1024 KB divided by 20 KB is equal to 51.2. Therefore, there are 51.2 files stored in 1 MB folder. So that's how you compute it. So it's quite easy if you just get the smaller value so that it's easier for you to compute the file storage that is needed. Okay, so next we have number 3. How many pictures of 679.5 KB size can be saved in 1 gigabyte folder data storage? So we can convert 1 gigabyte to KB first so that we can divide it here. So 1 GB times 1 GB, and 1 GB is equal to 1024 MB, times we have MB. So 1 MB is about 1024 KB. So we're going to multiply this to get 1,048,576 KB. Then we're going to divide 1,048,576 KB by 679.5 KB, which is equal to 1,809.45. There are 1,809.45 pictures that can be saved on a 1 gigabyte folder. So that's how you compute using digital information, units of digital information. Okay? Okay, so this is another table that you can use for better computation of your values so that you can get better computation. So these are the file storage capacity in bits and bytes. So terabyte, petabyte, exabyte, and zettabyte. So this is the latest type of memory that we have on the market. Okay, so this is another example of the table that you can use in computation of your values. Okay, and this is the new standard Electrotechnical Commission standard, and this is what we follow nowadays in computing the units of measure for digital information. Don't be confused with data storage and units of digital information. They are different in terms of values. So when we say when I say data storage in your activity sheet, you're going to use the rounded values. So 1000 KB, 1000 MB, 1000 GB, and so on. But on the units of digital measure, it's quite different because this is the exact values, okay, in bits and bytes. So in summary of our discussions, we have discussed the different components to be measured. In terms of, we have memory, which is either a ROM and a RAM. We have your data storage, your hard drive, your SSD, optical drive, and external drive, the different processors, video card. And we also have your processors, memory, and hard drive information that needs to be understood when buying your PCs or laptops. We also have your graphics card, your computer storage. We have discussed the units of measure for digital information and binary numbers. So for our practice in terms of digital information and data storage, what I want you to do now is to answer self-check-in activity on page 46 to 47. and pages 53 to 54 that will be submitted on our LMS. And then you're going to answer activity 3 and activity 4. For activity 3, we're going to compute storage capacity, and you're going to convert storage capacity information, and we're going to use also the different units of measure for digital information. Okay, and for activity 4, you're going to convert binary numbers from decimal to binary and binary to decimal, and you're going to add, subtract, and multiply binary numbers. So once you have finished these activities, you will be submitting it to our learning management system. For our quote of the day, everything that is beautiful and novel is a product of reason and calculation. This is according to Charles Baudelaire.
Thank you for watching, and I hope that you have learned many things from our discussion. See you on our next lesson. Keep safe and God bless.